Assalamualaikum warahmatullahi wabarakatuh. I am JNS Saribs. A chi-square test is a statistical hypothesis test used in the analysis of contingency tables when the sample size are large. In simpler terms, the test is primarily used to examine whether two categorical variables, dimension of the contingency table, are independent. Don't follow the assumptions of parametric tests, especially the assumption of a normal distribution. If you want to test a hypothesis about the distribution of a categorical variable, you need to use a chi-square test or another non-parametric test. Categorical variables can be nominal or ordinal and represent groupings such as species or nationalities because they can only have a few specific values. They can't have a normal distribution. Note: parametric tests can test hypotheses about the distribution of a categorical variable, but they can involve a categorical variable as an independent variable. And then the chi-square formula. So this is the formula of chi-square test. Both of Pearson chi-square tests use the same formula to calculate the test statistic chi-square. So ito yung formula. The larger the difference between the observation and the expectation, the bigger the chi-square will be. To decide whether the difference is big enough to be statistically significant, you compare the chi-square value to critical value. When to use a chi-square test? A Pearson chi-square test may be an appropriate option for your data if all of the following are true. So, you want to test a hypothesis about one or more categorical variables. If one or more of your variable is quantitative, you should use a different statistical test. Alternatively, you could convert the quantitative variable into a categorical variable by separating the observation into intervals. And the sample was randomly selected from the population. There are a minimum of 5 observations expected in each group or combination of groups. And then the types of chi-square tests. So the two types of Pearson chi-square tests are the chi-square goodness of fit test and chi-square test of independence. Mathematically, these are actually the same test. However, we often think of them as a different test because they used for different purpose. Chi-square goodness of fit test. The chi-square goodness of fit test is a statistically hypothesis test used to determine whether a variable is likely to come from a specific distribution or not. So, using the chi-square goodness of fit test, the chi-square goodness of fit test check whether your sample data is likely to be from a specific theoretical distribution. We have a set of data values and an idea about how the data values are distributed. So, chi-square goodness of fit test, you can use a chi-square goodness of fit test when you have one categorical variable. It allows you to test whether the frequency distribution of the categorical variable is significantly different from your expectation. Often, but not always, the expectation is that the categories will have equal proportion. So, for example, the hypothesis for chi-square goodness of fit test, expectation of equal proportion. Null hypothesis, the bird species visit the bird feeder in equal proportion. Into alternative hypothesis, the bird species visit the bird feeder in different proportion. and expectation of different proportion. Null hypothesis: the bird species visit the bird feeder in the same proportion as the average over the past 5 years. And to alternative hypothesis, the bird species visit the bird feeder in different proportion from the average over the past 5 years. So, using the chi-square goodness of fit test, so what we need? So, we have bags of candy with 5 flavors in each bag. The bag should contain an equal number of pieces of each flavor. The idea we'd like to test is that the proportion of 5 flavors in each bag are the same. For a group of children's sports teams, we want children with a lot of experience, some experience and no experience share evenly across the teams. Suppose we know that 20% of the players in the league have a lot of experience, 65% have some experience. The idea we like to test is that each team has the same proportion of children with a lot, some or an experience as the leagues as a whole. And to apply the goodness of fit test to a data set, we need. So data values, they are a sample, random sample from the full population. Categorical or nominal data, the chi-square goodness of fit test is not appropriate for continuous data. A data set that is large enough so that at least 5 values are expected in each of the observed data categories. So this chi-square goodness of fit test example, we collect a random sample of 10 bags. Each bag has 100 pieces of candy and 5 flavors. Our hypothesis is that the proportion of the 5 flavors in each bag are the same. Is the chi-square goodness of fit test an appropriate method to evaluate the distribution of flavors in bags of candy? So we have a simple random sample of 10 bags of candy. We meet these requirements. So our categorical variable is the flavors of candy. We have the count of each flavor and 10 bags of candy. We meet these requirements. Each bag has 100 pieces of candy. Each bag has 5 flavors of candy. We expect to have equal numbers each flavors. This means we expect 100 over 5 equals 20 pieces of candy in each flavor from each bag. This is more than the requirement of 5 expected values in each category. For 10 bags in our sample, we expect 10 times 20 equals 200 pieces of candy in each flavor. This is more than the requirements of 5 expected values in each category. Based on the answer above, yes, the chi-square goodness of fit test is an appropriate method to evaluate the distribution of the flavors in bags of candy. So figure 1 below show the combined flavor counts from all 10 bags. So this is the bar chart of counts of candy flavors from all 10 bags. Without doing any statistic, we can see that the number of pieces for each flavor are not the same. Some flavors have fewer than the expected 200 pieces and some have more. But how different are the proportion of flavors? Are the number of pieces close enough for us to conclude that across many bags there are the same number of pieces for each flavor? Are the number of pieces too different for us to draw this conclusion? Another way to phrase this is, do our data values give a good enough fit to the idea of equal numbers of pieces of candy for each flavor or not? To decide, we find the difference between what we have and what we expect. Then, to give flavors with fewer pieces than expected the same importance as flavors with more pieces than expected, we square the difference. Next, we divide the square by the expected count and sum those values. This gives us our test statistics. These steps are much easier to understand using numbers from our example. Let's start by listing what we expect if each bag has the same number of pieces for each flavor. Above, we calculated this as 200 for 10 bags of candy. The table 1 comparison of actual versus expected number of pieces of each flavor of candy. So this is the table. And now we find the difference between what we have observed in our data and what we have expect. The last column in the table 2 below show this difference. So this is the table 2. Difference between observed and expected pieces of candy by flavor. So some of difference are positive and some are negative. If we simply added them up, we would get 0. Instead, we square the difference. This gives equal importance to the flavors of candy that have fewer pieces than expected and the flavors that have more pieces than expected. And then for the chi-square test of association, the chi-square test for association is used to determine if there is any association between two variables. It is really a hypothesis test of independence. The null hypothesis that the two variables are not associated independent. The alternate hypothesis is that the two variables are associated. A survey was done to determine if a job satisfaction was related to income. A total of 901 people participate in survey. So this is enter the data into an Excel worksheet as shown below. So select all the data in the table above including. And this is the chi-square test for association input. And the chi-square test of independence, you can use a chi-square test of independence when you have two categorical variables. It allows you to test whether the two variables are related to each other. If two variables are independent and related, the probability of belonging to a certain group of one variable isn't affected by the other variables. So for example, the chi-square test of independence, null hypothesis, the proportion of people who are left-handed is the same of American and Canadians. And to alternative hypothesis, the proportion of people who are left-handed, difference between nationalities. Last one, the data analysis by the computer. Data analysis is a process of inspecting, cleansing, transforming, and modeling data with the goal of discovering useful information, conclusion, and supporting decision making. So in our research, the PC is used in its emulation mode to access the data in the mainframe. And the mainframe SPSS or SAS is used to do the initial statistical analysis. When necessary, subsets of the data are transferred to the PC, where other computer programs are used to analyze the data.